Welcome to another science class with James. Now let's take a look at two questions that one of my students asked me. The first one is this. Marcus set up the experiment as shown below. He placed they are identical wooden blocks, right, in the container. So I think there's some grammatical errors here in the question. Next, he placed the wooden blocks on 4 different surfaces labeled M, N, P, Q, R. These are 4 different surfaces referring to this Q surface, P surface, N surface, and M surface. Alright. Now, next one. He added 10 gram weights one by one into each container until the wooden block attached start to slide across the surface. So if it requires very few weights to make this block move, it means the surface must be quite smooth because there's less frictional force to overcome. If he needs to place many weights inside, then to make the wooden blocks move, then it means that there is more frictional force between the bottom of the wooden blocks and the surface. So you look at the information given in this table. Surface P must be the roughest surface because that surface requires the most number of weights before it can start moving. Before the blocks can start moving, be dragged down by this container. So I put this under the side under the roughest, the scale. This is the roughest. And then N must be the smoothest surface because all I need is just 2 weights, 2 10-gram weights, the least number, and therefore it is the smoothest surface. 5 is larger than 2 but smaller than 8, so 5 of course will then mean that Q is the second smoothest surface. I put it here. 8 10-gram weights is very big. It's not as big as 10 but it's bigger than 5. So if the surface M here, I will then describe this as the second roughest surface because I need to put in 8 10-gram weights before this wooden block can be dragged across this surface. So this is the second roughest surface. Having this worked out, now I can answer this easily. M is smoother than P, that's true, it's smoother than P. Rougher than these two, that is true. Most gravitational force is acting on the block sliding on surface P. That is not true because all these blocks are identical blocks. Right? The identical blocks means that their mass is the same and therefore the amount of gravitational force acting on each of the blocks here are the same. So right, it is false. So anything with B is wrong. Therefore I know that 2 and 3 is wrong. Now, frictional force between the wooden block and the surface had to be overcome before it starts sliding. That is true. You need to exert, the frictional force acts in a direction opposite the direction of movement. So this is the direction of movement. And the force that is pulling the block in this direction must be greater than the force pulling that's exerting on the block in this direction. This force must be greater than this frictional force. So C is true. Then the minimum amount of weights required to move the wooden block on the surface N is this one, 2 blocks, right, is 20 grams. Each block is 10 grams. 2 blocks will be 20 grams. Therefore D is also true. 2 blocks, 2 times 10 grams is 20 grams. Therefore the answer is A, C, and D. Right, it's 4. The next one is quite a standard question. Now, and the working is quite straightforward. Now you are given 2 substances with different melting points and boiling point. Take note that melting point is also another word for freezing point, right? Now, so as you know, matter acts in 3 states: solids, liquids, and gas. So if substance X is placed in an environment where the temperature is below 217 degrees Celsius, it will be a solid. Once the temperature that X is in rises to 217, it will start to melt into a liquid. And when it increases the temperature to 700 degrees Celsius, this liquid X will turn into a gas. This is where it boils. How about Y? Y has a different melting point. So for substance Y, you need to increase the temperature all the way up to 420 degrees Celsius before it starts to melt into a liquid. Any temperature below this, those in pink for example, would mean that this substance X remains as a solid. And once the temperature hits 420, Y will start to melt into a liquid, right? And we know that the boiling point of Y is at 900. So once you heat it up to 900 degrees Celsius, it will start to boil and turn into a gas. Of course, at any temperature here, it can also turn into a gas. That's called evaporation. Now we are asked this question: at what temperature should Cheryl heat the mixture such that one substance stays as a liquid, one substance stays as a solid? Okay, so very clearly to me, the temperature must be between these two ranges. It must be more than 217, because once it is more than 217, this one becomes a liquid, and it cannot exceed 420. So once it's between these two, that means that Y remains as a solid because it doesn't reach the melting point. So the only number that's between 217 and 420 is 300 degrees Celsius. I hope this short video helps you. Take care. Goodbye.